All right, here we are for another episode of our Learning Health System podcast. I'm particularly excited about this one because when I first met Parsa, he talked to me about this maturity model, and he basically told me this was all I needed to understand. Everything else, if I understood this was everything. I don't think that's actually completely true, Parsa, for the record.
It may be actually.
But it's certainly a excellent map. For those of you that don't know, there are 8 maturity levels. We're going to go through them all. Were there 6 to begin, and did you add some, or were there always 8, or how did that happen?
Yeah, well, you can imagine, like anything and everything in life, my understanding of these things has evolved and changed over time.
Yeah.
I used to think of them as 8. But then now I believe in 6, and the latter 2 are emergent features of the previous 6. So those are the real, I would say, destinations, right? But that itself has its own levels. Now we are being a little bit cryptic, I think.
So let's dive in.
Before we go into the specifics of these layers, allow me to give you some perspective about what the whole thing is, right? We are talking about the roadmap, a maturity model in which you can build infrastructure necessary for learning health system. As I mentioned, you can't do it in a day, and you can't buy it wholesome or build it wholesome as a monolithic system for learning health system. It is inevitable that you have to build it in a series of strategically motivated and planned steps. When we talk about these competition levels as separate levels, it doesn't necessarily mean that there's serial one needs to finish before the other can start. These are competencies that have dependencies to each other. You should imagine them as a network of interoperable functionalities that depend on each other. It is possible that a healthcare system can start investing in all of the layers with this understanding of what the layer is and how it should interoperate with the layers adjacent to it or before and after to it. So this is not a recipe for how to temporally link them. It is about you have to make sure that you have these competencies and you have to know how they interact and interoperate with each other in order to build the whole system.
Well, let's start at the beginning, the foundational layers, the hole you have to dig.
So the foundational, yes, the way I think about these foundational data systems is the way one should think about precision medicine, right? Everything you know about patients, their biology, their demographics, their care experience, their clinical data, all of the data that as a health system we collect as part of our operational and administrative processes, imaging, waveforms, anything that we, time series data, clinical data that we collect through our EMR and our devices and the clinical systems, environmental data, socioeconomic data sets, you need to have a system of not only collecting them, but also integrating them together as a holistic representation of patients and make them analysis ready. That's the foundational system level 1. It doesn't mean a data lake that you can just pour your data in. It doesn't mean building a clinical data warehouse. To make that foundational level 1 work, you need a master entity indexing capability that can resolve identity You need to make sure that you resolve identity of every single analytic entity in your system efficiently across all data sets, right? So entity resolution is a huge part of having an analysis-ready linkable data set. And it also works for de-identification. Yeah. When you are giving a data set to a set of researchers that want to investigate something, you have to obfuscate identities of the patients across multiple data sets in a way that you can re-identify them later if needs be.
What other components do you need in the film?
Well, you need data lineage. You need to know from a learning health system perspective, understanding where the data came from. Is it fit for use? Can you use that data to reproduce? Can you go back and find the data to be able to reproduce the same experiment again? Is a key criteria, and you have to be able to do it again at scale. Nowadays, we are talking about explainable AI. Let me give you a very modern example. I showed a clinician a score by a predictive model that said this patient is at high risk of ARDS or respiratory failure. This patient needs to go to ICU, needs to be intubated, mechanical ventilation, very expensive, very painful interventions may result from scores that we're sharing with clinicians. It can change patients' experience in a radical way. It can take us to a court, quite honestly, if we screw up. Where this score came from, what were the exact data points that we use to inform that AI model's inference, and where did this data originate from which screen of EMR can we look into to identify whether or not this data was correct and correctly collected and correctly transformed before you push it into an analytics.
So we need data lineage.
Needs to be there.
We need. What else do we need?
Well, you need a process that can bring all of the hundreds of thousands of data points into your analytic system in the most real-time fashion possible. Do all of those data wrangling and transformations and data mappings in the most harmonious way possible all the time, 24/7. So you need a robust data ingestion framework that knows all of the 100 places that you siphon off the data and all of the channels that will require to receive that data downstream. As part of that data ingestion, you need a way of making unstructured data like clinical notes indexable and processable, massive scale natural language processing.
Do you think that's going to be as important in the world of LLMs that we live in now?
Absolutely. And LLMs have opened the door for really large scale and very efficient processing of these documentations. So yes, I think we are already there in that sense.
And is that it? So any
no
other
quality
problems?
of the data? Sure. I mean, we always say garbage in. This is true about almost every computer system, right? Garbage in, garbage out. How do you know that your data is not garbage? And creating metrics for quality of the data that not only human beings understand in terms of the fit for use and consistency and completeness and all of those things that are important for quality, but also are machine understandable. So you can actually use machines to monitor quality of data and fit for use of the data across many use cases is also critical.
This is just maturity level 1.
Yeah, this is just maturity level 1, right? HIMSS has a analytic maturity model that we've talked about for years. Our maturity level 1 maps to maybe HIMSS level 3 or 4 in terms of how many competencies as foundational you should have in your analytic infrastructure to align with learning health system competency level 1. Because as I mentioned, it's not about how do you just as a health system bring your data and put it in a data lake in a way that you can access it and analyze it. It's about how do you support that learning cycle, not as a singular health system, but as a node in a network of collaborating health systems. And again, you need that, what I would call knowledge representation, your ontology management, your vocabulary, not only representation, but also mapping across terminology systems. So knowledge graphs are parts and parcels to learning health systems from my perspective at the foundational level 1.
Oh, is that the
you
end
want
of
to spend this entire
No,
podcast?
I'm trying to go to the next level. I keep being like, are we done with level 1? Can I go to level 2?
We can get a little bit of a level 2. So level 2, from my perspective, is now that you have a way of putting the data together and track it and understand it, but how do you open it in a privacy preserving way, in an accountable way and responsible way, in a compliant way for all downstream use cases, right? It's about how do you enforce compliance? How do you represent compliance from the regulatory and protection of human subjects in a way that every time that you access this data set that we just created at the foundational level 1, someone is watching it, someone is authenticating it and says, yes, this use case, this user has approved protocol to access this sets of the data for this purpose, for this long.
But for that level of integration, you're going to require some sort of IRB integration, I would imagine.
IRBs, data use agreements, and not only just, IRB representation is actually a big part of the maturity level 2. We believe that a review and governance process should be implemented on top of all of your data assets if you want to open it for analysis at scale in a compliant way. And we have designed a system for that we at Montefiore have deployed that allows us to represent use cases. We started with IRBs, 2 IRBs actually at Montefiore that authenticate a protocol, authenticates members of that protocol, approval level for the data used as per that protocol within a time frame, and monitors it. So when the protocol runs out of date or a person leaves the membership of that protocol, or for some reason IRB stops that protocol, all access to the data sets will also stop.
So there are fewer components in level 2, but they all rely on level 1. They're all interwoven. Yeah.
You hit the nail right on the head. These levels are really like gears. They're interconnected, and without that interconnection, you just have a bunch of stuff, which is what most health systems do.
Have we covered everything in level 2? Is that what we need to go from level 2?
Yeah, well, I gave you a very broad perspective, right? You have to have a way of representing people and their analytic workspaces. You should differentiate between public and private spaces, and monitor, audit, and trace all of that, link it to your what I would call your contract or protocol representation, IRB representation, so you know who is doing what. And then you have to also have a way of moving between different levels of identification, right, as per protocol. Not everyone in the same protocol needs identified data, or some people can work with fully de-identified data, where the other ones will require to be able to work with fully identified data. the management of who can see what when for what purpose is also part of the level 2 that needs to be represented as part of your data architecture.
So now we have level 2. Level 3?
Level 3, now that you've built the analysis ready data sets and your compliance on top of that, you're really ready to open it and make it
so I'm going to stop you there because
everyone.
So that's interesting. So up until this level, you really haven't talked. I mean, you kind of don't have things.
We haven't talked about
use, right? You have these systems, but no one's using them.
That we have built the foundation. We dug a big ditch and we filled it with stuff, foundational things. So this is where you democratize. You make the data accessible, because now you can trace, track, monitor, audit. You can serve a catalog of all of the information that you have. I didn't even mention your cataloging system that should be up to date. As any data set comes through, you should be able to resolve it. You need to make this data accessible to everyone, everywhere. You need toolings. And when I say tool, I mean two things. Really software platforms and technologies that allow people to independently, without having deep understanding of the data sets and the data lakes and SQL and Python, to ask and answer clinical or operational questions on their own.
We are talking about self-serve here, right? Where this system should be...
self-service, real-world evidence tools. They only expect that the users understand the research methodology, they understand how to define a cohort of patients rigorously. Those clinical and research-oriented definitions are all you need to interact with these kinds of tools. And you should be able to provide this at scale to everyone. And not only those tools are important, from my perspective, you need to combine it with training. You need to have training and literacy programs that pushes this understanding to the community so they can understand how to design a study in a way that if you provide data and analytics, they can actually create an evidence. This is part of this evidence generation thing, that they can end up with results that can be translated to practice.
So that's interesting. So now you're not talking about a technology system, you're actually talking about a culture.
Exactly. Actually, culture is a level 3, a data literacy. If I want to actually define level 3, I would say you have provided equitable and scalable access to all of your data assets, along with all of the training that it takes to create a data literate organization, an organization that has the data-driven and analytically driven culture. So the definition of level 3 is probably separated from the technology, and it's about its dissemination as a literacy and culture in your community.
So culture is about people, and I happen to know that level 4, you start adding machines. So let's talk about level 4.
The level 4, we appreciate that, especially these days, analytics have made such an impact and comeback that you can't really address big and complex problems without them. So maybe I would say level 4 is the competency of applying those really advanced big data analytics and artificial intelligence, generative AI kind of analytics in a responsible and explainable and trustable way. Again, I'm combining the social and human constructs next to the technical and architectural constructs, because they need to go hand in hand. And as an organization, you should be able to deploy these technologies with that social and perhaps even political construct these days together. So if you want to name names, level 4 is about responsible, trustable, and explainable analytics. AI, machine learning, deep learning, Gen AI, all of that.
And I know you sometimes group level 4 and level 5 together.
I always do, because we are talking about learning health system, right? From my perspective, if you are doing a research, if anything that you do that you don't have any idea how it translates to practice and feeds back to your analytics in that loop, is not part of your learning health system.
And that's because level 5 is translation to practice, right?
Yes, level 5 is translation to practice. It's building all of that interoperability and interconnectivity technologies that will allow you to push that analytic to your practical delivery of care processes. Epic, right? If you want to name a name, again, maybe not level 5 is about making your epic most systems that have made millions, if not billions of dollars of investment in building their EMRs, would like to benefit from it in most scalable way possible. And this is it. This is how do you integrate all of these learning and data and analytic enterprise into your Epic in a way that you benefit from all of that investment, right? And it has several aspects. The level 5 has several aspects. One is translating research to practice. If you have a fantastic clinical decision support system that you have validated, that works with deep learning and generative AI and what have you, how do you deliver it at the point of care to all of the clinicians and care delivery systems that can continuously benefit from it and provide feedback to continuously improve it? The second aspect of the translation to practice is how do you involve your clinicians and investigators at the point of care in learning and in research? Your research systems should have a presence within the clinical environments and systems in a way that they can understand and they can participate in research, because we're talking about the learning cycle and creating a learning experience for everyone. In my definition, if you remember, of learning health system, training and learning of everyone, and innovation, participating in innovation was part of the definition. And level 5 is all about that. So everyone that is walking across a health system is participating in some level of learning, some level of research, and making facilities to provide that as part of that vision of learning health system that has a technological component that needs to be understood and implemented and integrated into your architecture. And the third aspect is creating a technology or infrastructure for real-world pragmatic clinical trials, large-scale research, again, not just in a system level, but a collaborative network of systems level. These three things go hand in hand and create the level 5. And if you think that way, by the time they reach that level 5, you have become a pharmaceutical system, a delivery of health system, a translational research system. You have become all of it, because you can go from 0 to 100 for all of your research needs inside the health system.
So what's left? What's level 6?
Well, we just talked about health system. We didn't really talk about it. So patients don't live inside the hospital.
They don't. Hopefully they don't stay.
They live where they live. They work where they work. So they are at home. They are at their community. Level 6 is that remote health system, distributed health system where tentacles and parts and pieces of your learning connect with the patients and engage them in their own research, in their own health-seeking experience and their care experience where they live. Whatever it takes to decentralize care, decentralize research, decentralize interaction with patients, and reside in the patient side and not in the health system side, are competencies of level 6.
And then you said levels 7 and 8 are manifestations of those 6 levels.
If you have a health system that collects all of the data from all patients' experiences, including those that happen in where the patients live, you have now built infrastructure for precision medicine, especially with kind of algorithms and analytics that we have these days that can personalize and look into all of the clusters and patterns that exist to identify the best care for you, where you live and how you live your life, precisely in the most patient-centered way possible. So patient-centered care, precision medicine.
People have been talking about precision medicine for many, many years, and what you're saying is that if you really want to give it or provide it, you need to have these 6 layers of a learning health system in order to really give precision medicine.
Yes. Of course, we're not talking about islands of excellence, right? You can have a little clinic that does this one thing for this one disease or for this one specific set of patients. That's not what we're talking about. We're talking about system level, right? How Montefiore Health System or, I don't know, Vanderbilt or Columbia's of the world can deliver precision medicine at scale for all patients uniformly, equally, equitably, and within that learning cycle. That's what we're talking about. How you scale precision medicine.
So if level 7 is precision medicine, what's level 8, the final level? Completeness?
Yeah, the final, that's all we talk about, learning health system.
It's enlightenment.
So if you can deliver, if you can deliver precision medicine at scale, you have also built what it takes to arrive at the definition that I used in the beginning, right? A health system that can learn from every single patient experience to improve the health and the care of others as well as that patient iteratively. Learning health system is achievable when you have a way of precisely dealing with patients one by one and dealing with patients as a whole, as a community, and dealing with care as a system, going from the micro level to macro level using this data and learning architecture. Of course, there are multitudes of human processes and data processes, analytic processes, and governance processes that play a role in becoming a learning health system. We are just talking about data and analytic processes, the vehicle, the instrumentation of learning health system.
I think this is great for today. I tell you what I would love to dive into next time is maybe some of the AI ML models that we're building around level 4 that rely on some of the deeper systems. I think we can have a great conversation about that. But for now, Parsa, thank you very much. It's always a pleasure.
Thank you. Absolutely. Thank you very much.
Until next time.